Okay, let's try another one.
Was your first time?
I'll probably still be doing exercise time. I know, right? We do so much crap. We like making
Okay, second function here. Y is equal to 2x squared plus 7x plus 5, all divided by x minus 3 times x plus 1. And our goal is to graph it like we did here, but now we don't have Desmos to give us some hints. Okay, so what do? Okay, I would want to factor the numerator. So what would the factors be for our numerator if we factor that out? 2x I heard.
plus 5.
Plus 5?
Plus 2. Is that right? 2x plus 2 is x plus 1. Oh wait, why was it?
So if you're doing the double up, if you had the 2x plus 2, you'd have to get rid of that extra factor, which would drop us to x plus 1.
Okay, yeah, but I can't do that.
Okay? So then these would be our factors for both the numerator and the denominator. And honestly, that is the first thing I do anytime I have these rational functions, factor everything out. Because back here, when we had the factors, it told us a lot about the function. All right, well, what did the factors tell us about this function?
X plus 1 out of there.
So x plus 1 is going to divide out. Okay? So what does that mean about the asymptote that would have been at x equals negative 1?
It's not. It's just the whole.
Okay, the asymptote doesn't exist. What about the intercept that was at x equals negative 1?
That intercept is still there, though.
That intercept doesn't exist either.
Oh, dang it. What is, I'm so confused.
Okay, so let's think about this. If I'm listing out domain, though, I can still say x doesn't equal positive 3 and negative 1. It's still a domain restriction, but it doesn't become an asymptote or an intercept anymore.
Okay.
All right, so what else do we know? Okay, that point would become a hole. So hole is that x is equal to negative 1. What's the y coordinate, though? How do I figure that out? So if I plug that negative 1 back into here, I can get the y coordinate. So that's going to be 2 times negative 1 plus 5, all divided by negative 1 minus 3. So what do I get?
Negative 3/4.
It's 3 over negative 4? Yep. So that hole is going to be a negative 1 and negative 3/4. So on my graph, whatever I'm graphing, I'm going to get to that point, and instead of continuing my graph, I'm going to put an open circle and then continue on past it. Okay? So that's the coordinate of our hole. All right, what else do we know? I heard mumbling about x-intercepts and vertical asymptotes. Not sure what numbers were said, though.
The vertical asymptote would be x equals 3.
Okay, so the only piece left over in the denominator is the x minus 3. If I set that equal to 0, I'm going to get x equals 3 for that vertical asymptote. Okay, and where are you getting the negative 5 halves? If I set the numerator to 0, I will get x equals negative 5 halves. So I'm going to put that in coordinate form, negative 5 halves, 0. Okay, what else would be helpful on this graph? Okay, Desmos would definitely be helpful, but unfortunately you don't have that. So what about the y-intercept? Because that was the other option that was presented. Okay, plug zeros into the x's. Which one do we want to plug it into?
Probably the top one for some reason.
For some reason?
I don't know. I just feel like that's what you're gonna say.
I'd rather plug it in here.
Oh, okay. Well, I didn't
Why?
know. Oh, I guess it would be the same one.
You should get the same thing.
Nuts.
This is less to plug in, though. Okay, and that's really the graph we're doing, just with a hole in it. Okay, so if I plug in a 0 here, I get 0 plus 5 in the numerator, 0 minus 3 in the denominator.
Negative 5/3.
negative 5/3. So then coordinate form 0, negative 5/3. Was there anything else over here that we found before we started finding coordinates for the graph? Horizontal or oblique. So how do I find a horizontal or an oblique asymptote?
It's the same. Well, kind of.
So it'd be
It's the
2x over x.
No, isn't it x squared?
Okay, so horizontal asymptote.
Isn't it x squared?
So I could look either one here. I've got a 2x squared over x squared. But if I'm
Either
looking
way,
at the one I'm actually graphing,
It cancels it out.
I'm going to say 2x over x. But either way, it's going to cancel down to
2.
2. What does that mean?
Y equals 2.
It's
Or y
It's this.
can't equal. 'Cause it's
Y equals 2. It's a horizontal
y
line.
for the range.
Because it's consistently getting close to 2. No matter how big x is, that ratio is going to be approximately 2 as it gets really large. Okay?
Nuts.
So we've got our domain, we've got a hole, we had an x and y intercept, vertical asymptote, and a horizontal asymptote. Lots of good information that we can put onto a graph. So let's plot what we know so far. Okay, vertical asymptote was to the right 3. So we're going to plot that in. Horizontal asymptote was up 2. I'm going to put that in. X-intercept was negative 5/2. Put that on our graph. Y-intercept negative 5/3. Puts us right there. Okay, and then we had a hole, the other thing at -1, negative 3/4. So that's going to be about right there, just an open circle. I'd say that left side is pretty defined now.
Yes.
It just goes like
Okay, so as we go to this right side,
connect the dots.
I'm just going to connect those up and approach my vertical asymptote. Okay, making sure not to fill in that hole though, because that is an open circle. Okay, on this left side, what's happening?
We just plug in the points, I guess, the coordinate.
Okay, well, looking at it though, what do you expect to happen?
Oh wait, no, we passed that part.
Horizontal asymptote.
It's going to come up and approach the asymptote.
I thought we were past that
Now,
part.
the question is, does it cross it? Because over here, we crossed the asymptote. How do we know whether or not we cross it here?
It's not between 2 asymptotes. You know what I'm
Well,
saying?
what was the asymptote?
Which, the vertical or horizontal?
Horizontal.
2.
Y equals 2. Let's take that asymptote and see if it ever equals our function. Okay? So does it cross the horizontal asymptote? That's the question we're asking here. So I'm going to take that 2, which was our horizontal asymptote, and set it equal to our function. And I'm going to do the reduced function because that's the graph we're really finding here. So I've got the 2x plus 5 divided by the x minus 3. How do I solve that?
Times x minus 3.
I'm going to multiply this off, so I get 2x minus 6 is equal to 2x plus 5.
Take 6 to one side of that.
Okay, so x's, I can subtract the 2x to get rid of that one. I can add the 6 to get rid of that one. So 0 is equal to 11.
Which is not true. So
That's not a true statement.
can't cross it.
So then the answer is no, it doesn't cross the horizontal.
Well, would it
asymptote.
ever cross, or is that just the? It does cross sometimes.
Sometimes it
Oh,
does.
so it's awful that if we assume.
What's the point of the
Okay,
asymptote
well-
if it crosses it?
Asymptotes describe end behavior. Okay, not central. What happens is x gets really large on the outsides. Okay, so like here, if I would have taken this function and set it equal to our asymptote, which was 0, well, that's how I find an x-intercept, right? I'd already done that step, so I didn't have to do it again. Whereas here, that asymptote isn't on the x-axis. I haven't already completed that step, so I had to think, does it ever cross that?
So we have, okay, that's awful.
So yes, you're going to want to check
That's
that
pretty
every single
sad.
time.
Why did I do that? Why did we do that last year?
Because we were probably nicer last year and didn't cross it as much, or ever. That's my guess. That's why we didn't have to do that last year. Okay, so left side of the graph is good. Now, let's think about what we would expect on the other side. What I expected down here, or what I expected up here? Why would you guys expect up? I would agree with that.
Because it's positive.
Okay, one, it's positive. Can't have what?
You can have like on both like bottom or both on top, right?
We could. There are times where you can have both bottom or both top. Not as often, but it does happen.
This is bad.
Okay? What do we not have?
Oh, an x-intercept.
An x-intercept.
Yes.
Okay? I only had one x-intercept. So that would lead me to believe that it's going to be up here. Because otherwise I can't approach that horizontal asymptote. How can we check that?
Oh, it's garbage.
Plug in something on that right side. So here I'm going to come over and say, well, let's plug in a 4. Because 4 is on the right side of that horizontal asymptote. Well, what do I get if I plug a 4 into my function here? So 13 over 1, so just 13. So right 4 up 13. We're going to say that's 13 right there. Okay, that's definitely above the horizontal asymptote. Okay, so then it's going to approach vertically, and eventually it's going to drop down and approach horizontally. Here, that it doesn't cross. That becomes our graph of that function. Questions on that one?